Hello guys, welcome to my channel, and let us give you some more vigor and fighting spirit in handling mathematics paper 2 in your coming exams for 2025. Obviously the curriculum and the type of questions that these are may slightly differ in terms of the exact content. The most important, guys, is the techniques, the tools, the tricks, the knowledge. If all is applied well, it can work anyway. This is just to emphasize you need to practice anything you come in contact with so that you can give yourself a better chance at performing at your optimal, if not exceptional level. Now we're going to look at this question. We have done the Euclidean section for this question paper. Please take note, it's a higher grade paper, meaning most of the questions will require some serious thought. Okay, so let's start with question 3. It says we are not to use a calculator. Not a problem. So this is 3.1. Now 3.1 tells us that sec of 751 degrees is equal to k. Now remember, this is a big angle. There's 2 revolutions plus something extra. Let's see what is let's just say 751 minus 720, which is 2 revolutions. It's 31 degrees. So obviously, guys, we need to reduce this. So this is the same as sec of 2 times 360 degrees plus 31 degrees. So it doesn't matter even if we've got multiples. Once we've got integer multiples of 360 or 180, we just use the same reductions that we have learned, which is just to take what we have. So we always show this as a ratio, so we can see safely that sec, now remember 360 plus, it's in the first quadrant in principle, so this is sec 31 degrees is equal to k over 1. Now we draw our terminal arm diagram, so we know this is in the first quadrant. So this is x, y, origin, and that is our terminal arm on the Cartesian plane. Great, so we know that this angle is essentially 31 degrees. And what would be this one? If that is 31 degrees, that should be 59. Because these are complementary angles. So always, guys, work things out very quickly. Don't delay. Maybe let's push it up to save some space. Okay, so all of that leads to this diagram. And then what is sec is the reciprocal of cos. Okay, so we know that sec is 1 over cos. And what is cos? Is adjacent over hypotenuse. Now this one is going to be hypotenuse over adjacent. Okay, so this is what we will have. So essentially we work out things. So x squared plus y squared equals r squared. We know this from Pythagoras. Now this implies that essentially 1 squared plus y squared equals k all squared. I don't like to waste time, guys. Y is going to be the square root of k squared subtract 1. And that's it. It's positive y because we are on the positive y-axis. So this is the square root of k squared minus 1. Okay. It helps to do this without needing any invitation. As you can see, this is nothing but a grade 11 question, so to speak, looking at it, and essentially just a higher grade one in that we are doubling the revolutions there. Okay, let's start. 3.1.1. We need to solve for cos 31 degrees. So what is cos 31 degrees here? Cos is adjacent over hypotenuse, so this is going to be 1 over k. All right, that's it. This one is simple. This one is simple, so we get 2 marks for this one, because we have not done. In fact, I think the second mark comes from simplifying this to that. So we get our 2 marks. 3.1.2 says we need to solve 2 times cosec of minus 121 degrees. Okay, now here, once we see negative angles, I mean, for me, whether you add 360 or whatever, it doesn't really matter. For me, this is going to be 2 into minus cosec of 121 degrees. Okay, great. And then when we FOIL this out, this is going to be minus 2 cosec. Now 121 is a big angle. We need to reduce it. So this is in the second quadrant now. This is 180 degrees minus, let's see, 31, is it? Let's say 180 minus 31. Nope. So let's check the other angle. So this is 180 minus 59. It gives us 121. Can you see, calculating that angle is good. See when it becomes our absolution. So this also implies, now we've got minus 2 times cosec. Remember, cosec is positive in the second quadrant, just like sine. So this is just going to be cosec 59 degrees. All right. I don't know why I'm writing this. This is an equal sign. This is an equal sign. We are calculating. All right, so this is now easy. So this is equal to minus 2 into cosec 59. Remember, sine is opposite over hypotenuse. Now cosec is going to be hypotenuse over opposite. So this is going to be k over 1. Okay, great. So what do we see here? So this is effectively minus 2k. Done. Okay, an interesting question there. All right, not a problem. So we're scoring 3 marks. Obviously, this reduction, the final reduction, usually gets the mark, right? Right, and the final answer gets the mark. Great. So essentially, what do we see now? Well, this calculation of that angle, because this is what mattered here. Sometimes you get a mark, sometimes you don't. So you see that calculation together with this, because I mean, we didn't use this, so it didn't matter. So that calculation of that angle is the 3rd mark. That's what this drives us into. So we have 3.1.3. We need to deal with this tan of 329 degrees. Okay, this is equal to, now 329 we need to reduce. So this is the same as tan of 360 degrees minus, let's see, is it minus 31? 360 minus 31. Yes, it's the one. So minus 31 degrees. Now we sort it out. Now 10 is negative in the fourth quadrant. So this is what we do. And we sort it out. So let's see. What are we going to get? 10 of 31. This is going to be opposite over adjacent. So this is minus into the square root of k squared minus 1, all divided by the adjacent, which is 1. This is effectively minus the square root of k squared minus 1. That is it. Alright, so what is that, guys? 3 marks. Again, any reduction is a mark. The final answer gets a mark. The opposite side there gets the third mark. Okay, so all of these steps, guys, are key. As you can see, whenever we use something that was not necessarily shown, we get a mark. The extra mark is there. So this is very easy, nothing complicated right there. So we're chowing, we are chowing. All right, let's get to 3.2. Now 3.2, we need to simplify this. We need to simplify this business right here. So we've got 10 of minus 207 degrees times cot 333 degrees minus this fraction over here. So this is going to be sine of x minus 360 degrees times cosec of x minus 90 degrees. Okay, divided by cos x. Now, this is more of an identity type of a question, you know, more of an identity type of a question. All right, let's do it. So this is what we have. Now, folks, we simplify as best as we know how. Of course, this is going to be a ride, an uncomfortable ride. So we first reduce this. Now, 10 of a negative angle is minus 10. Now I'm going to start working through this one. 207 is nothing but let's say 360 minus 207. Oh, it's a big angle. I don't want one. So this is in the third quadrant, so to speak. 207 is essentially 180. Okay, let's say 207 minus 180. This is 27. So this is nothing but 18 degrees plus 27 degrees. So we don't want to waste any of our time. That angle there, this is the cot of 360 degrees minus, let's see, 360 minus 27, since we got a clue, yes it is, so 27 degrees times, minus this fraction over here. Now this fraction is sine, or by the way, we can reduce this, but I don't want to do reductions separately, so let's just write it again. Okay, so this is what we have. Now we just keep going, guys, systematically. All we have to do is just to keep going. Our work is a tough one, so Now I don't know why I didn't put lines in here, because I'm giving myself a very steep hill already. So this is minus into, now 10 in the third quadrant is positive, so this means it's going to be just minus 10. But anyway, let's just reduce this properly without rushing. This is minus 10, 27 degrees into, now 360 minus 27 is in the fourth quadrant. Cot is going to be negative there. Right. So minus, now we do the reductions here. Now what is going on here? What is x minus 360 on the Cartesian plane? If we look at it nicely, if this is the origin, this is y. We know that this is 0 degrees or minus 0 degrees also there, or it could be 360 degrees, or it could be essentially minus 360 degrees. So minus 360 degrees is here, right? So this is minus 360 plus x. So when we are adding the angle, we are going clockwise. So this means we're moving from here to there. Can you see? So that means our terminal arm is effectively in the first quadrant. And what is sine in the first quadrant? It's positive. So this is going to be a positive sine x into cosec of minus 90. So minus 90 is here. So this is minus 90 plus x. So we're going into the fourth quadrant. We're going anti-clockwise. So it means our terminal arm is in the fourth quadrant. And cosec, not cosec, cosec is negative. So this is minus. But now what is the co-function of cosec? Is sec 90. I mean sec x, sorry. Nice and easy. This is all divided by cos x. Okay, we're going on nicely indeed. So we've got that whole situation nicely. So let's keep doing what we do best. So this negative times negative is positive. So essentially we have 10, 27 degrees times, now cot is a reciprocal of 10. So this is 1 over 10, 27 degrees. Minus, now this is not a big deal. If we look at it, we will see it. Okay, let's see it. So this is sine. Let's just do this. I'm trying to think, guys. So this is nothing but sine x. Of course, negative times negative changes to positive. And this is sine x times sec is 1 over cos x. Now we do this division with cos x over 1. So be systematic. So this is this division line. So I'm just trying to expand it nicely so that I don't get confused with my solutions looking strange. All right, we continue, guys. So what happens here is magic. Magic happens. So we simplify as we go along. So this goes on to be 1. And then we have plus, we still write sine x. Now these multiply nicely. We divide by cos x. So we flip this one, it becomes 1 over cos x. Okay, so we do the final thing. So this one must not be too long. So we have 1 plus, now sine times 1 is just going to be sine x divided by cos times cos. This is cos squared x. Okay, Great, so this looks nice. It looks right. Okay, so what are we going to do now? We continue. So we see that this is nothing but 1 over 1. So we still simplify algebraically using our BODMAS. Now what are we going to see, guys? We will have a common denominator, which is going to be cos squared x. Now this 1 divided by 1 is itself multiplied by the numerator. This is cos squared x. And then what we have here is going to be plus just sine. Wait a minute. This sine of ours is squared. Yes. Mistakes, guys. So this is squared. Okay, this is squared. That is squared. So this is sine squared x. Careful, folks. So sine squared x. So when the algebraic expression is quite hectic, it's easy to make these errors. Né? Good. So what is that? Using the square identity, this is nothing but 1 over cos squared x. Now the square on the numerator gives us 1. The square on the square root of the denominator gives us cos x. Now what is this? This is still an identity. This is sec x. Alright, now this is fully simplified. Alright guys, so this is all was expected to be done by a mathematics student. Of course, this is a bit lengthy, which explains why we need a bit of space, not the nonsensical space that you are given. I don't understand who designed that idea or came up with that idea, but it's anything but laziness. I think it's just laziness on the part of the people who designed this, because they want the marking process to be easy while they're making it very uncomfortable and essentially unfair for the students. But we can rant all we want, no one is listening, so yeah, we may as well just keep quiet. Whatever. So what matters now, guys, is essentially this reduction. Remember, this reduction on its own, when the negative comes out, is good. All right, that is very good. That is the first one. Don't worry about the angle. The first reduction matters. All right, okay, all right. But again, do I really want to mark it there? Maybe. Let's see. And then we come to this one. We haven't done anything. Okay, maybe let's not be silly. I believe this reduction is proper. This is what gives a mark. This is what gets a mark. That reduction gets a mark. That reduction gets a mark. Okay, 4 marks. And then whenever we use identities, doing that reciprocal, we get a mark. Whenever we do reciprocals or using identities in general, we get a mark. Okay. Now, when things, divide into 1 and they are survived by 1 because it is the only thing remaining, so it's not a big deal. Here, we can multiply things again. That doesn't matter. That doesn't matter. This is nothing but BODMAS directly applied. We don't get very far there. Then we're using the lowest common multiple here, or just the common denominator, not a big deal. But when we use identities, it's a mark, right? Right. And then we get this out. When we're taking the square root, it's nothing but BODMAS in terms of the ordinals or the exponential expressions. nicely, and then when we use what we use as identities, we get a mark. So how many marks is this? 1, 2, 3, 4, 5, 6, 7, 8. So we are told that we're supposed to get 10 marks. Well, this is still algebra, so maybe to take out the square root, we can say, okay, using BODMAS applied, that is the 9th mark. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Where is the 10th mark? Where is the 10th mark? Okay. What I'm thinking is there's so many places now to consider, guys, but we can say, what about the extra mark? Because I can't find a place where it makes sense to give that mark, honestly. But maybe we can say this negative, meaning part of the reduction there, we can give an extra mark there, just to make up the 10 marks. And this is for a total of easy 18 marks, as you can see. Now, a student who is non-suspecting could have fallen into the trap of wanting to reduce this to 10, right? Yeah, a non-suspecting guy or girl could have gone into that trap. So sometimes you need to delay certain things so that you can get to the answer. Because if you start to have 10 squared x, I wonder. But I think the square identities do have something like that, isn't it? Let me check. If we have one, if we've got cos squared x plus sine squared x equals 1. If we want to make 10, we can divide by cos throughout. So in maths, we can divide by anything we want. As long as we make sure it is balanced. So this one goes, we get 1 plus, this is 10 squared x. Then this is essentially 1 over cos is going to be sec squared x. Right. So literally, even if you did it, even if you diverted here, it would still work out. As long as you know your identities, guys. So meaning you need to know stuff. So here you could have chosen to go this route. Say, okay, this is nothing, 1 plus 10 squared x, which will simplify to, now 1 plus 10 squared x, we can see it's sec squared x. The square root of sec squared x is just sec x. Okay, maybe it's even easier and shorter. whatever. So guys, please explore your options at times, because this is sometimes, the quickest way you can solve a painful problem. So this is one of the options one can explore to see. And you can see, guys, if you forget, generate things. Because when you see something like this, just think of square identities. If you don't know the one for this particular one, write the original. Manipulate it. Don't depend on trying to get these from the information sheet, because you're not going to find them there. Remember, none of those things are going to be added. Only the generic things are going to be here. The derivatives of those are never going to be included. So one needs to find a way of remembering how to perform mathematical gymnastics and sort up problems. Okay, guys, that's nice. That's easy. Let's move on to the next question. Trig functions. Now with trig functions, what are we given? We are given f of x is equal to cos of half that angle x. Okay, now what can we learn? We always look for that coefficient of the function itself. It is in this case an invisible one. So what does this invisible one represent? It represents what we call the amplitude. Okay, now the amplitude in this scenario gives us two things. It gives us a maximum value of our function and a minimum value of the function. So it is the absolute value of the coefficient. The maximum is always the absolute value of the coefficient, and the minimum is always the negative version of that, or meaning the negative absolute value of that coefficient. So that is good. But we know, what are these things, guys? These things are nothing but y values of turning points, or at turning points. These are y values at turning points. So remember that. So maximum and minimum tells us about y values at the turning point. Now we come back and say, okay, if we scan through, the angle has a coefficient which is a half. What does this half tell us? It tells us that the period is going to be the original for the cosine function. The original is 360 degrees. Then we divide by the coefficient of the angle. Then we get 720 degrees. Now, what are we going to get? From this period, we get things that we call intervals. Intervals is the current period divided by the 4 quadrants. Then we can see that this gives us 180 degrees. So what is the significance of intervals? This is what we would call the spacing between the critical values. Okay, now what are critical values, guys? This could be an x-intercept. It could be an x coordinate at the turning point, right? And essentially an x value at the y-intercept. But the y-intercept is not really that much of a big deal, but it's more like the starting point for each graph. So I think if we keep this in mind, this is what we are trying to get to. So we are saying here, the interval between two critical values, be it an x-intercept to the turning point or an x value to the x-intercept, to the y-intercept, it should be a period, a spacing of 180 degrees interval. All right, so that's it. Now let's look at g of x. G of x is essentially sine of x plus 60 degrees. Okay, now this is horizontally shifted to the left, so this is a transformed sine graph to the left by 60 degrees. Okay, how do we interpret issues here? We will see that technically also we have an invisible one for the coefficient. Now what is that? That gives us our amplitude. Now what does this amplitude give us? It gives us essentially our maximum value, minimum value. So the absolute value gives us the maximum, then the negative absolute value gives us the minimum. And we know what these are now. I'm not going to explain them. These are the y values at the turning points. Then we scan across and we see that essentially the angle itself has an invisible one in there. So what does that invisible one give us? It gives us the fact that the period is going to be the original period for the sine graph. And this one is also 360. Remember, sine and cos have an original period of 360 degrees. Then we divide by the coefficient of the angle. Now we see that our period is nothing but 360. Now from our period, we want to sort out intervals. It will be the current period, whatever value we find, we divide it by the 4 quadrants, and that gives us a spacing of 90 degrees. Okay, nice and easy. So that means for this graph, the critical values are going to be separated by an interval of 90 degrees. But now we have a bit of a situation. Problem now is that there is a horizontal shift of our graph to the left by 60 degrees. Now, what are we supposed to do? Of course, ideally, we first look at this period, this interval. We need to compare it to that before we can move on, because if we're going to graph this simultaneously, we need to see if these two intervals can accommodate each other. For example, 180 can accommodate 90, or 90 can bring about 180. So that is good because these are factors of each other. 90 is a factor of 180, sort of. 180 is a multiple of 90. So when that is the case, it's easy. We don't worry about trying to unify them because the smallest interval will be the one defining the intervals, right? Right. But now we have a problem. We need to unify the situation between these two now. Because what we see now, there's 60 and 90. Now 60 is not a factor of 90. Neither is 90 a multiple of 60. So here we look for the highest common factor. And what is the highest common factor between these two? It's 30 degrees. Okay, so this means this will be our interval on the grid. So this is going to be the interval on the grid now. So be very good, guys, at learning and mastering things, because once all of these things are good, life becomes so sweet because you just approach these things with ease. You just go into that exam with your head. All right, okay, so we have done a bit of revision for you guys to understand this question so that we can perform maximally. Now, what we need to do is to solve the problems. We need to solve the problems. Okay, guys, so I just cleaned my canvas. It looks like it was dirty from previous work. Anyway, let's keep moving. We have a lot of work to do. So the first question says we need to solve simultaneously, meaning the points of intersection. Can you see? Simultaneous equations are just point of intersections of two functions. All right, so let's do it. 4.1. What do we have? Sine of x plus 60 degrees is equal to cos of a half x. Now, from our inspection, we can see that this angle is certainly not the same as this angle. So we can't say these things are equal. But now, when we've got sine and cos, we can change sine to cos or cos to sine. It doesn't matter what we want. Now we're going to use our knowledge of cofunctions. So this is the same as having been cos of 90 degrees minus x plus 60 degrees is equal to, this one is cos of a half x. Now we have a nice situation because we've got cos and cos. Now obviously if this is cos of this, whatever angle, this is a compound angle if not a complex angle, divided by, is equal to the cos of this, half an angle. But if these two are equal, it means these two angles are also equal. So this implies that essentially 90 degrees minus x plus 60 degrees is equal to a half. But now remember, we're going to use the knowledge of general solution. So we're going to say plus or minus a half of x plus k times 360 degrees, where k is an element of integers. Right? That is what this means. Okay, we just solve. Now when we break this bracket, it's going to be 90 minus 60. Then we can split the solution. So this is going to be 90 degrees. Man, come on. 90 minus 60 is going to be 60 degrees. No, 30 degrees. Minus x is equal to, we can choose the positive version, plus k times 360 degrees. Or we can say 30 degrees minus x is equal to the negative version of that angle plus k times 360 degrees, where k is an element of integers. Okay, this is what we need to do. Then we go on. Now what is the next thing to do? We just keep solving. So we bring x to that side, we take 30 to the other side. When we bring x, it's going to be minus x minus a half x. So this gives us minus 3 over 2x equals minus 30 degrees plus k times 360 degrees. Or we take this one, it becomes minus x plus a half. So we get minus a half x is going to be equal to minus 30 degrees plus k times 360 degrees, where k is an element of integers. Okay, so we keep going, guys. So for me, solving with general solutions saves me a whole lot of pain of wanting to think about other things and what. Just a moment, guys. Okay, guys, so what do we do now? We just simply divide by negative 3 over 2. So we know that x is going to be, cross multiply that, that's 60 divided by 3, that's 20 degrees. Minus, because this is negative again, this is 720 divided by 3, it should give us 240. 720 divided by 3 is 240. So this is minus k times 240 degrees. Or we cross multiply the 2, we get minus 60, we divide by negative 1, we know that x is going to be 60 degrees minus, of course here it's going to be minus k times 720 degrees, where k is an element of integers. Okay, we always write that. Now once our general solutions have isolated x, we can solve for x. Therefore x is equal to a set of values which we need to find now. So of course when when k is 0, we have 20 and 60, so we can write these 20 degrees, 60 degrees. Is there more? Let's say k is 1, so this is 20 minus 240, so this is outside the domain, because remember we are given a domain. This must be between minus 60 and 300. But now when k is, say, when k is here, what do we have, guys? I don't see anything. If k is 1 here, it doesn't work. So yeah, k when it's 1, it doesn't work on both equations. Let's say k is -1. Now this is minus 240. 240 plus 20 is basically 260. So we can see that 260 is within the domain. And then when k is -1 here, this is too big, it's outside the domain, so we can lock it. So these are the solutions of x, right, in that given domain. Nice and easy, guys, nice and easy. So can you see, general solutions help us to not miss a solution. But of course, it depends on how you want to see it, but it's easy to lose the path here. It's very easy. Okay, guys, so obviously we're going to get marks for these. Technically, we're going to get a mark for each general solution right here. Because, I mean, we are scoring how many marks here? 7 marks. So this is already good 5 marks right there. Am I really going too far? We only have 2 marks to score. Obviously, changing to core functions, that's good. So, yeah, man. I think this step is good as well. So we have our 7 marks in the bag. Okay, let's get to 4.2. Now 4.2, we need to use the axis provided in the diagram sheet to draw sketch graphs of curves of f and g for this given domain we just solved. We need to show clearly the coordinates of all turning points and the end points on the intercepts, and the intercepts with the axis for a very good 10 marks. I mean, this is a very simple. So let's go find the grade. Okay, guys, so I've copied that grade into our answer book. So let us keep moving in the right direction. Now, guys, we need to work. Remember, we worked out our intervals already. So we saw that the best is 30. So we can say this is 30 to 60. So we write 60 here because that's what we want. So this is going to be minus 60. And then this is 30. This will be 60. This is 30. This is again another 60, which gives us 120. And then 30, we get another 60 there, which is 180 degrees. That's 60, we get another 60, which gives us 240 degrees. Another 60 lands us at 300 degrees. Okay, good. So we have sorted our grade. And remember, the smallest scale must be the highest common factor so that we can cover that shift nicely. Great. Otherwise, 90 is a factor of 180 and 180 is a multiple of 90. And 30 is also a high common factor there, so meaning it will be nicely accommodated. So we are good. So let's look at this one. If we say this is comma 5, so this is 1. So this is minus 1, okay? Maximum and minimum. We are ready to hustle this one. Now, guys, we can start with the cosine graph. Cos of 0, I mean, cos of 0 is 1. So this graph goes all the way to the top. So we are here. Right. Now, we are saying half of 60 is 30. Now, 30, cos of 30 is root 3 over 2. And root 3 over 2 is 1,8 some change. So let's say 1,8 is over here. Let's say that's 1,8. Ne? Okay, maybe it's a bit too far. Let's say 1,8 is over there. So all I want, guys, is to do this. I want to copy, paste, and then move this thing so that I can get the same grid over there. Right. I can go masmaqhelana. So one has to make sure that this thing is on the line, guys, because if it's not on the line, it can make life a lot uncomfortable. All right. So I think it's on the line. Now what I'm trying to do, folks, is to try and get a straight line. Okay? So it's to try and get a straight line. Okay? Does it look right? Looks okay to me. Okay? Looks okay to me. Now, what are we going to do? We want to extend this on either side. These are just temporary lines to assist us to draw our sketch without problems, okay? So, of course, the grid may not be nice depending on how it is done. So, yep. So now what are we going to do, guys? Well, we can remove what we had put in there. Okay. Those were the means to an end. Now we can start sketching. We can start sketching. What was this? Green. Okay, now cos of 60 is root 3 over 2, which is going to be here. Right. And then we come to 120. Now 120 by, that is 60. So cos of 60 is a half. And then 180, half of 180 is 40. Sorry, half of 180 is 90. Cos of 90 is 0. So can you see it's very easy? 240, this is nothing but 180 plus 60. So this is in the third quadrant. So this is more like cos of 60 there. Right. So with 300, this is the same as cos of, wait, half of 240. Let me not make a mistake here. Yeah, this is 120. And 120 is reduced to minus 60. 60. So yeah, that should be fine over there. And then 300, half of 300 is 150. Yep, 150, and therefore cos of 150 is what? Masivele sifake njalo. This is the same as cos of 30 in the second quadrant, so to speak. No, not in the second quadrant, but in the fourth quadrant. So that would be, wow, okay, no. Second quadrant. Remember, this 150 is 1 in the second quadrant, so it should be negative root 3 over 2. So that is our end point. And then, of course, half of 60 is 30 degrees. So cos of minus 30 is going to be positive root 3 over 2. So there are the points. So let's join them. Okay, guys. So there is our graph. Sometimes it's not as beautiful as you want it to be. Now let's graph the next one. We go to the sine graph. So we start here. Minus 60 plus 60 is 0. So sine of 0 is 0. When it's 0, it's going to be sine of 60. Sine of 60 is root 3 over 2. So it's going to be on this line. And then when we have 60 there, it's going to be 60 plus 60, which is 120. So this is the same as sine of 60. So it becomes a straight line. So this means we need to consider halfway because we need to find our maximum. Now we look at this and let's see what is going to be this one. 30. Now 30 plus 60, that's 90. Sine of 90 is 1, so it comes up there. Okay. All right, okay. Yeah, this is now getting a bit naughty, because this is suggesting these graphs are equal there, and it's not the case, you know. Yikes. Okay, let's just sort this out quickly. Okay guys, I tried to sort this out. So at 60 we're going to be grounded, we're going to be there, and then at 30 we reach 90. Okay, that's fine. Then we come back here, we are equal, and then sine of 120. Now 120 plus 60, that's 180. It grounds here. And then 180 plus 60, that's 240. So essentially it should be sitting there, right? Because sine of 240 is this one. And then again 240 plus 60, that is 300. So sine of 300 is the same as the sine of 60 in the fourth quadrant. No, don't lie, when a man. Sine of 300 is the same thing. So if we get this one, then we must find the turning point here. That means we consider the 180 plus 30, that's 210. 210 plus 60 gives us 270, and we know sine of 270 is there. And then of course 300 plus 60 is 360. Sine of 360 grounds. It grounds. Okay, so let's draw the graph nicely. Okay guys, so there are our graphs nicely drawn, and we can now remove our lines that were essentially a mere means to an end. All right, so we wanted this on our grid, and nothing more, nothing less. So we have labeled G, we have labeled F, so our lives are essentially good. Now what are we going to do? We get our marks. We will get our marks. Obviously guys, our turning points have been shown nicely, the shapes. So if we think about it, we can say this maximum is important. So we can show that this is at 30 degrees, so to speak. And perhaps we can show this one as well. This is going to be 270. No, 210 degrees. Right. So those are the smaller little things to consider, I suppose. And then, yeah, the turning points are clear. Y-intercepts, very clear. X-intercepts, very clear. Nothing is out of the ordinary here. All right, okay, all right. So that's it, guys. So let's have a look. We have our 10 marks, actually. However, they are distributed. Sometimes there's no clear logic on those marks, okay? Let's answer the next questions. Question says, use the solution obtained in question 4.1 as well as the graph drawn in question 4.2 to determine the x value or values where x is an element of the given domain, for which the following. Now we are saying f of x is less than g of x. So we want to scan and see when is the graph of f below the graph of g. Now can you see this is the graph of f? So we follow it in between this point right here. If we drop this into the x-axis, okay, this is what we see. Now, can you see this is nothing but the point of intersection? This is a point of intersection between the two graphs. And what did we see from our general solutions? 20, because this is before 30. Okay? So maybe it's a bit outrageous though. It's a bit outrageous. It's right here. Yep. So this would justify 20. Okay? That would justify 20. We might even show it if we like and say that is 20 degrees from what we just worked above. Okay. So as we scan this graph here, they are equal. But immediately after this point, the graph of F is below the graph of G, and that satisfies the inequality. We follow it as we get here, they are equal again. So this means in between. So in this interval, these two are essentially doing the things. And then when we scan beyond 60 degrees, another point of intersection, the graph of F is above. Up until this point of intersection right here. So if we take it back to the x-axis, again, this is another point of intersection between the two graphs. So what is that? So obviously this is beyond 240, so that should be the 260. We can write it here because that is also important. So we can see that as we get here, the graph of F is below the graph of G. So those are the intervals that we need to cover in answering the question. So we want to cover that interval and that interval. So those are the two intervals. I don't see any other. So yeah, so we write it nicely. We can say essentially x must be less than 60 degrees, greater than 20 degrees. Or x must be less than 300 degrees or greater than 260 degrees. Okay, so that is good, guys. That is good, guys. So for me, honestly, these ones are both important because we needed to drag them from above, right? But this 260 for me is more important, provided everything is good. So this is how I believe those 3 marks are scored. In fact, I didn't answer the question. So this is 4.3.1. Okay. Now let's do 4.3.2. We need to find the product of the y values of the two graphs so that it's either less than or equal to 0. Now we need to look at the signs. Of course, these graphs are both positive on this end. Okay. And we scan them all the way. So this is 0. And of course, this point is important because it will give us 0. But after that, they are both positive. So the product is greater than 0. So it's not included. And this happens all the way until we get to 120. And we know that the product is 0. And then immediately after 120, this one is positive. This one is negative. Now that product is good up until we get to 180. Now this product is 0, so this is what we want. So it looks like to answer this next piece, we're going to have to focus on this interval. Right, maybe let's write it at the bottom so that we don't intersect our graphs. So this is the interval that we want. because the product is negative and it's 0 at the ends of that interval. And then here they are both negative, and that product is positive, so it's greater than 0. We don't want it. Here they are equal, and they continue to do so up until we get to this point right there. Now at that point, that product is 0, and it is essentially what we want. So we've got 3 solutions. We've got that first one, so we can say x must be equal to minus 60 degrees, or x is going to be this interval less than equal to 180 degrees greater than or equal to 120 degrees, or our x should be equal to 300 degrees. So each one of those solutions gets a mark, at least for a 3-mark question. So guys, this was nothing but an easy 23 marks. Not really difficult. And as we can see that our general solutions are proven by the graph that indeed they are correct. So this is what is necessary for trig functions. Of course, I've given you some ways of knowing some noteworthy areas so that you can master your craft, because these graphs can be a bit of a situation, especially when given like this, where there is a lot to make up for along doing the question. All right guys, so let's get to question 5. So we're just going to be doing this trig parade right now, and we are not stopping, not at all. We are not stopping. So let's get to question 5. Now question 5, we are to determine the general solution of that equation. So that's not a problem. A very simple question. Question 5, we have 2 sine x plus cosec x minus 3 is equal to 0. So what are we going to do? Well, our 3-step approach, guys. So this is 2 sine x. There's nothing we can do about this, but this is an identity, so it's a reciprocal of sine. So this is over sine x minus 3 equal to 0. Of course, this implies, now in fact, what can we do, guys? We can multiply by the common denominator. What will we have? We get 2 sine squared x minus 1, plus 1 minus 3 sine x equal to 0. So what do we notice, guys? We have a quadratic. So this implies that we have essentially 2 sine squared x minus 3 sine x plus 1 equal to 0. So we always write our quadratic in standard form. So what can we do? We attempt to factorize. It usually works. If it fails, we use the quadratic formula. 2 sine x sine x. This is positive, this is negative, so both brackets must be negative, and of course 1 and 1. So we've got minus 2 sine x minus sine x. It gives us minus 3 sine x. 2 sine x times sine x, it becomes 2 sine squared x. Minus 1 times minus 1, it gives us plus 1. So that expression is good. So what do we do now? We continue and say, okay, it means sine x is a half, right? Or sine x is 1. And both these solutions are valid by knowing the original sine function. But now we wanted general solutions, so we're going to do it. So we know that x is going to be arc sine of 0,5 plus k times 360 degrees, or x is going to be 180 degrees minus arc sine 0,5 plus k 360 degrees, or we do this one, it's going to be x equals arc sine of 1 plus k times 360 degrees, or x is 180 degrees minus arc sine of 1 plus k times 360 degrees, where k is an element of integers. Okay, so this is what we need to consider. And we continue, guys. So essentially, I can just make a conclusion right now, because you know what? This is it. After this, we just dish the solutions. Therefore, arc sine of 0,5 is 30 degrees. So x must be 30 degrees plus k times 360 degrees. Or x is, so this is going to be 180 minus 30, gives us 150 degrees, plus k times 360 degrees, or x is, now this is, arc sine of 1 is 90 degrees, 180 minus 90 degrees is 90 degrees, so we just write this one as 90 degrees, plus k times 360 degrees, where k is an element of integer. So please don't forget to write that story every time. So this is the general solutions. It's done. Not a complicated thing. Nothing but algebra. So we get a mark for each. It should be like that. Essentially, this is, for me, 1 for each one of these. But I would believe we can get a mark for both of those again. And perhaps these solutions, 1, 2, 3, 4, 5, 6, 7. Now, factorization is a mark in maths, and writing in standard form is another mark in algebra. So this is how I believe these 9 marks are scored. So this was 5.1. Okay, good. Now let's do 5.2. So 5.2, we have 5.2.1. Now we are told to write down an expression for cos 2 theta in terms of cos theta, that is only. So we know that cos 2 theta is the same as 2 cos squared theta minus 1. And that's it. Easy 1 mark. Don't do the other ones. You'll be in trouble. So 5.2.2. We now need to prove the identity. And then, of course, with identities, we'll look at the complex side. A double angle is a complex angle. A square is a complex situation. And we've got yet another double angle with a square. So the left-hand side looks more complex. I mean, a single angle is simple. So that is essentially more simple. So we look for the complex side. Left-hand side equals 2 cos theta times cos 2 theta sec theta times sine squared 2 theta. Okay, now let's sort it out nicely. This is equal to, there's nothing we can do with cos theta, but cos 2 theta, we can do that. If we are told to do that, it means it's a clue. We need to use that. Right. Plus, now sec is 1 over cos using our identities, times, now this one, sine 2 theta is going to be 2 sine theta cos theta all squared. That is essentially how we handle this business nicely. What do we do next? We FOIL out the bracket, so we get 4 cos cubed theta minus 2 cos theta, and we have plus. Now here we need to deal with this business. Obviously when we square this whole thing, the numerator becomes 4 sine squared theta times cos squared theta. Now when we multiply this denominator through, it is all divided by cos theta. Okay, now look at the magics. Cos theta will take the square. Nice and easy. So we have 4 cos cubed theta minus 2 cos theta, essentially plus 4 into, we can use our identities again. The square identity says sine squared theta is 1 minus cos squared theta times cos theta. That remained. Now we can FOIL this out and that in, whatever. So we've got 4 cos cubed theta minus 2 cos theta, plus when we multiply by cos theta here, it's going to be 1 cos theta times 4 becomes 4 cos theta. Then we multiply in there, it's going to be minus, we will have 4 cos cubed theta. Look at the magics again. These two eliminate each other, and so the remainder matches, is a coalition, coalition part. Now 4 of these minus 2 of these, we get 2 of those. We get 2 of those. This is equal to the right hand side. Please do say that. Don't underestimate the power of concluding on any calculation or writing that you get to do. So can you see, guys, 3-step approach, very good. And in fact, it is a directive in my opinion. It takes you from the beginning to the end without you needing to manufacture a lot. Of course, there are some areas that you can look at to derive some direction, but it's usually very easy to follow. So very easy, 7 marks here. So what is the story, guys? Whenever we use identities, we get a mark. So that's a mark. That's a mark. So easy, 3 marks straight up. Now, what is the story? Whenever we use an identity, we get a mark. Great. So that's it. So for me, you know, when we're just handling algebra, there's nothing really strange or special about it. But let's see, this is 1, 2, 3, 4. This is essentially worth 4 marks, to be honest. Now the extra 3 marks is, you know, whatever. But obviously, guys, this is a bit more complex. There's 2 things we are doing. So maybe we get a mark for this and that as well, I guess. So how many marks now? 1, 2, 3, 4, 5, 6, 7. Because this answer was already given. So yeah, easy 7 marks there. Okay, let's get to 5.3. Now 5.3, we have 5.3.1. We are told to write down the expression for tan compound angle A plus B. Okay, That's not a problem. We know that tan of A plus B, we proved it in the previous video, so now we just transcribe it. So this is going to be tan A plus tan B divided by 1 minus the product of tan A, tan B. We proved it, easy. So if you forget, do it on the rough work and then write it down, because here you only need an answer. Once the question says write down, it means answer only is important. Of course, pay attention to the mark allocation. 1 up to 2, an answer only is good enough. Now the question says, hence if 10A plus B is 4 and 10A is 1, calculate without the use of the calculator the numerical value of 10B. So this means we're just going to take what we just wrote. 10 of A plus B is equal to the ratio of 10A plus 10B divided by 1 minus 10A, 10B. Now this implies we have 10 of A plus B, we are told is 4. Now since we are dealing with fraction, this is 4 over 1 equals 10A is 1 plus 10B divided by 1 minus 1 into 10B. Okay, we just handle just arithmetic now. This is 4, or you could call it algebra because there's still variables here. So we have 1 plus 10B divided by 1 minus 10B. So we do cross multiplication, a gymnastic of choice. This implies we can take the positive side. It's going to be 1 plus 10B is equal to 4 minus 4 10B. Now remember, multiply 4 to each of those terms. Multiply 1 to each of those terms. Now we collect what we call like terms. Now this comes here. We're going to get 4 plus 1. It's going to be 5. 10B is equal to, we bring out 1 to this side, it's going to be 4 minus 1, which is 3. We divide by 5, it's going to be 10. B equals 3 over 5. Alright, so that's the answer, guys. Not complicated at all. Yo, the line is slanted. See, when I don't have lines, I cannot really see if my writing is slanted or not. Because you see, the problem with me, when I write, the page has to, turn around. So the page for me looks like this. So I write towards my chest. So sometimes it's easy to miss how things are. Okay, it's not exactly horizontal, it's slightly slanted, So if we do this, you will see that usually the page sits like that, and then I write towards like that. So sometimes I miss the alignment easily. That's why my writing is like stepping up and down. I cannot write straight. Yay. Aqhelekanga futhi. Qhabo phambane. All right, okay, guys, what are we doing here? You know what, guys, this thing is crazy, man. This is good, it's nothing but algebra, and then the substitutions, that's all. Remember, this is still very much algebra. So again, very easy, 22 marks, guys. Nothing really out of the ordinary here. You take the marks, you smile. Now let's get to question 6. So that we can end trigonometry. This is more like a short course, guys, to assist, the preparation for the coming year. So don't worry about the real or main content of the subjects you're going to write, that, hey, in this syllabus, there's no sec, there's no cot, there's no tan compound angle identity. Remember, this can be asked in the exam. Even though it's not part of the syllabus, it's still an identity, and it is still maths. We are using the same principles that we use to prove anything. So be on the lookout. This can come to haunt you. So watch out. All right. Okay. All right. So now, guys, we have a situation. Now we're told in the diagram alongside triangle PQR is shown. Use the diagram on the diagram sheet or redraw the diagram in your answer book to prove that. Now I'm not gonna redraw. I have a diagram right here. Sine of Q, this angle. Sine of Q is this angle. Over Q, which is the side opposite that angle, is equal to the sine of P. There is P. Divided by the side opposite that. Okay, so what is to be done here? So obviously Q is our anchor, so what is best is just to extend this side. This is the construction that we need to do. Okay, after extending this side, we draw a perpendicular. We want to draw a perpendicular line to that one, so we must get 90 degrees. It may not be exactly perpendicular, but that's the idea. And then of course we break it up because it's a construction, so constructions must not tamper with us. Of course this one is a solid line because it was already there, you know. Whatever, guys. And then here again we break it up, so we can name this height H. That's it. That's all we need to do. That is all we need to do, guys. So obviously we need to look at this triangle as well. So we need to look at this small triangle and that big triangle. All right, so maybe let's call this point PQR. Let's say PQS. Let's call it PQS, but my S looks crazy. Let's call that PQS, okay? So what are we going to say? We can say given triangle PQR, right, easy as let's leave it, triangle PQR. What are we supposed to do? Sorry, what are we supposed to do? I don't even hear what I'm saying. Strange, guys, how sometimes you say things and you think you're saying the right thing, only to be shamed by listening to yourself talk nonsense, and you're like, what the hell? So this is what we need to prove. Okay, remember, for every proof we must do a construction. So what are we going to construct? We are going to produce PQ2S and draw perpendicular height H as shown. Of course, we use the diagrams given to annotate because we submit that along with this question. Now we get to the proof. The proof says, we can look at a particular triangle. The best is to look at the bigger one. We can say here, well, in triangle PSR, this is the one we want to look at. What do we know? We know that sine of angle P is, or must to, can be equal to sine of angle P is going to be the opposite, which is H, over hypotenuse, which is Q. So that's it. So therefore we know that H here is going to be Q sine P. That's fine. We leave that alone. We can say also, in fact, likewise, in triangle, say QSR. What is cooking there? We know that essentially sine of, by the way, this angle, we need to identify it, guys. I forgot to mention that. We need to calculate that angle. So we know that this angle is going to be 180 degrees minus Q, because Q is that angle on the inside. So before we start saying things, we can easily say, well, we know that angle R QS is going to be equal to 180 degrees minus angle Q. I'm using angle Q because we said that one was the other one. So what is this? These are angles on a straight line. It's a very important component of this proof. We can say then we know that sine of 180 degrees minus Q is going to be the opposite side, which is H, divided by the hypotenuse side. Remember, the hypotenuse is the side opposite the right angle, so that's going to be P. So therefore H is going to be equal to P sine 180 degrees minus Q. All right, okay, all right. So which is going to be P times sine of 180 minus Q is as good as sine Q, using reduction formulae. Now what do we see, guys? Each one of these expressions is equal to H. Okay, so what are we going to say? We can say, therefore, we understand that technically sine P sine Q is the same as Q sine P. Right, because each one is equal to H. Then we divide by, now what do we want, guys? We want to divide by these variables. So we divide by PQ. In maths, we can divide by anything we want. So we have P sine Q divided by PQ. Then we will have Q sine P divided by PQ. Can you see? Strategically, we can divide by anything. And if we do it, we must do it to both sides. Can you see? P takes P, Q takes Q into an invisible one. So we can make that final conclusion that indeed sine Q over Q is equal to sine P over P. The identity has been proven. Or should we say the law or the rule, the sine rule has been proven. So please guys, practice these things. You will be surprised when these things pop in and you are not ready to hustle the things. Okay, it's just 3 marks guys. So for me, this is what is important. Whenever we use a reduction formulae, this is important, but emanyana, maybe let's just do it. That is good. I mean, the rest of this gymnastics, guys, equating the two, okay, maybe substituting these is fine. Whatever, guys. This could be even more marks than is being given here, but you know what? The examiners have a different opinion. So let's leave it at exactly what it looks like. So that was 6.1, guys. Very easy. In fact, I forgot. The construction statement always gets a mark. Can you see? No man. It looks like this is all. Getting that, getting this. The rest is logical. Not a big deal. Let's get to the other questions. So 6.2. Okay guys, I hope you're enjoying the lesson. Now in the diagram alongside, triangle KMN is given with K as 2 theta, already indicated, and we are told that KM is equal to KN, and that is denoted by N units. Okay, then NM is K units, not a problem. Now we need to prove that K is equal to 2 sine theta. Sorry, 2n sine theta. All right, okay, all right. Remember, if we have a situation like this, this side is equal to that side. It means these angles are going to be equal because this is an isosceles triangle. Very important. And here, we're just going to use the rule we just proved. Easy. Annotate the diagram. Can you see this is 5 marks? We need to say some things. Okay, we're going to say essentially angle. Okay, maybe let's say in triangle KMN. What is cooking there? We know that angle N must be equal to angle. I don't know why I'm writing like this. It's always nicer to write with the cap. Angle N is going to be equal to angle M. These are angles opposite equal sides of a triangle. Given KM is equal to KN. I like to complex my stories because one could easily say KM is equal to KN given and therefore deduce that these two are equal, provide that reason, but you can do it all at once. To save some time, I mean, why not? What do we want to say now? We can say then, we understand that technically we want sine theta to come out. Obviously, guys, I forgot. We need to calculate one of these angles. My lord. My lord. So we are going to say, well, I don't know what I'm doing now. This is important first for me to get these angles. We can say also, I know that angle N plus angle M plus angle K should give me 180 degrees. This is sum of 3 angles of a triangle. It is this triangle we're still talking about. This implies, now we said these two are equal. We can decide to use n. So we can say 2 times angle n plus k, which is 2 theta, is going to be equal to 180. Now I don't want to prolong this inevitable situation. We transpose this and divide by 2. This is 90 degrees minus theta. Nice and easy. Okay, now we know that. We can say then, we know that technically we want the side k. So we can reverse, or we can write this ratio upside down. It doesn't matter. Or we can write it as we have just proven above. It's still not a problem. So we can easily say sine of n over the side opposite that angle. It's going to be n units. It's going to be equal to, same thing as the sine of k, for example, over k units, which is the side opposite it. This is nothing but the sine rule. All right, now we just cross multiply, or before we cross multiply, we know that this is sine of 90 degrees minus theta divided by n equals sine of 2 theta divided by k. We cross multiply. What do we get? Because we are interested in isolating k, so this is going to be k sine of 90 degrees minus theta is equal to n sine 2 theta. Now what are we going to do, guys? We shall divide. We want to isolate k, so we divide by sine 90 degrees minus theta. So what we end up with is k is equal to n sine 2 theta divided by sine 90 degrees minus theta. All right, this implies that k is equal to, we expand this, this is n into, this is going to be 2 sine theta cos theta divided by, we use cofunctions here, this is going to be cos theta. Great. So we can see the matrix. This is a product, so cos theta will take cos theta. Therefore, we can make a conclusion that indeed k is 2n sine theta. All right, guys, so you can see that these are easy 5 marks. You chew upon them like bubble gum. Right. So where are these marks? Where are these marks? So guys, this statement is powerful, and the end result of it, 2 marks. Setting up the sign rule, maybe not. But what is important for me is setting up these identities and, of course, using reduction formulae. This is a mark. So we have 1, 2, 3, 4. So obviously, guys, substitutions here, this could give us 5 marks. Or even setting up the sign rule could also be a mark, because this is specific rather than general at this point. So easy marks, guys. So please understand trigonometry. It's very interesting algebra of some kind. So 6.3. So let's finish up, guys. Now we are given this 3D structure, and of course I have taught you guys how to do these problems. From, if you want to use the most recent reference, would be the previous video on November 2024, paper 2, mathematics. I have shown and outlined what we need to do here. All we need to do is to always calculate all possible angles. Once we do that, we take a triangle where we are given most of the angles and at least a side. Then we work towards the common sides, because usually the secrets are there. Then we do our 3-step approach. Alright, in the diagram alongside, points B, D, and E lie in the same horizontal plane, and it's already shaded. Now BED is 120 degrees, BED. So this inside huge angle, maybe let's give it another color. That inside huge angle is 120 degrees. That's the only thing that's not indicated. And then we are told AB and CD are 2 vertical towers, and these are already indicated. AB is equal to 2 times CD. You can see this is H, 2 times H, already indicated. The angle of elevation of A from point E is alpha. That is already indicated. The angle of elevation of C from point E is 90 degrees minus alpha. That is also indicated. So obviously, folks, it means we can calculate those angles. We can calculate this angle. Okay, let's not use the same color. So that angle is going to be, obviously, if we add 90 here, we're going to get 180 from 180 to 180. So this one should be alpha. Right? Right, because those are complementary. They must add up to 90 degrees. If this is alpha, it means this angle right here is going to be 90 degrees minus alpha. Again, these are complementary angles. They should add up to 90. So we can see with these triangles, we have the most information. We've got all the angles and at least a side. All the angles and at least a side. So we can decide how we're going to go about our business here. Okay, now question says determine the length of BE in terms of H and alpha. So this is the side. Of course, now the examiner is making it easy. Otherwise, I could punish you guys and give you this question as the first question. Instead of 8 marks, I say 10 marks to drag along that too. Remember, this is how difficult questions are created, from smaller, simple questions. Then we just rubbish everything and say, find your way through. Sometimes in the final exams, the examiners become a bit friendlier to allow you some time to breathe. Okay, let's not waste time, guys. We've got 6.3.1. Now we can see that we need to work in triangle ABE. Now in this triangle, we just need to sort this thing out. We don't need that angle, so we can use the tangent of alpha here. So we can say tan E, okay, let's say tan of AEB is going to be the opposite side, which is AB, over the adjacent side, which is BE. Just want to be systematic, so this is tan alpha is equal to 2H over BE. We can say therefore BE, this is when we cross multiply and divide, is going to be 2H over tan alpha. So we have shown this in terms of H and alpha. So that's it. Substitution, answer. Easy, 2 marks. Nice. Now we get to the next one, 6.2.2. This is the big boy stuff, higher grade questions indeed. Now, this one was a standard grade question. This is a higher grade question. So can you see in a higher grade paper, you do get some free marks. Of course, this is the examiners trying to prevent an embarrassment of a student getting a 0. Sure. Anyway, or at least to save a decent mark if you were starting to gasp when you get here. Now prove that the distance between the bases of the two towers is given by, so what is the distance between those? This is this one, BD. Can you see? These examiners are very tricky. They're just going to use a bit of simple English just to get you freaking out. Well, we know what we need to do now. We can see that we need this triangle, right? Right. So we can say in triangle, the shaded one, it's going to be B, D, E. Doesn't really matter how we name it though, as long as we can use it. What are we going to see? We know that we need this side from this other triangle. So all we are going to say, we know and understand without a shadow of doubt that we are going to do this indirectly. We're going to say, well, tan of 90 degrees, now we're not wasting time, minus alpha is going to be the opposite, which is h, divided by the adjacent side, which is ED, because this is what we want. Now this is in triangle CDE. Okay. Of course, you don't need to explain this. Someone who sees what you're doing understands it perfectly. But you're just trying to say that even though we are talking about this triangle, we can actually bring in this other triangle because there's a common side there. You can say, therefore, our ED is essentially h over tan of 90 degrees minus alpha. Nice. So guys, this is not nicely simplified. So this is h over, now this is an angle in the first quadrant, so the cofunction of tan is cot. So this is going to be cot alpha. We leave it at that. Now we needed ED in this triangle. So now what are we going to say? We can start performing the gymnastic. Then we know we need the cosine rule because we've got the side, we have an included angle. We want the opposite side. So cosine rule works in there. So then we know that BD squared is going to be equal to BE squared plus ED squared minus 2 times BE times ED times the cos. Now guys, I do not have the time. Okay, maybe let's write it. Cos of BED. Because this is the cosine rule. Okay, in case someone is asking, what did we just do there? So this implies, of course guys, once you see the square root, just think of the cosine rule when you're looking at 3D structures or Pythagoras. Now we can just start by saying BD squared and not really waste our time with simplification. BE 2h over tan alpha, so this is squared, into ED, this is h over cot alpha. Good. Minus 2 into 2h over tan alpha times h. Okay, I'm on that silly dirty area. Cos of 120 degrees. Okay, running out of a space there. I'm running out of space. Cos of 120 degrees. Good. So BD squared is equal to, now we simplify this. This is 4h over 10 squared alpha plus, is it plus h squared divided by cot squared alpha minus, now this times this is going to be 2, wait a minute, it's going to be 4 h squared over 10 alpha cot alpha times, now cos of 120 is the same as cos of 60 degrees in the second quadrant. So this is minus root, sorry, it's minus a half, sorry. Using special angles. Uma ungazazi ususheshi uzoshabalala ngikutshela. Well, ke o jwetsa ke ntse ke le jwalo. Le ha o tlo tuka mollo monna. O tjhe, ho be le thwele. Ke o jwetsa. O tla etsahala dintho tse ngata ho wena. Now guys, what the hell? What the hell? Well, the hell is the hell, Mos. You see, Mos, this is the one. Now we can tell that the LCM here, in this whole scenario, is starting to talk a good language to us and is saying things that we want to hear. If we take the LCM here, we can see 10 squared can accommodate 10 alpha, cot squared can do it times 2. So this is going to be 2 times 10 squared alpha, cot squared alpha. Ne? Oskov. But what is going to happen? This negative will change to a positive right there because it only multiplies this term. So obviously, what do we do here? We take this, we divide by that, the 10 squared goes away. We get 2 cot squared alpha. So we're going to have 4h times, in fact, not 4. Now 2 will multiply there, it's going to be 8. 8, sorry, this is squared, guys. This is 8h squared cot squared alpha. We divide by this, the cot squared goes, so we get 2h squared 10 squared alpha, sorry. And then we come here. We are like, what? You know what? I kind of wasted time here, guys. Remember the magics here were supposed to have been done a long time ago. This is what was meant to happen. So yes. We don't need all of this. So this becomes our, LCM. So this remains 4. This remains 1. And then we get here. So this sign changes to a plus. So here, what do? This one is taken in half. So we're going to have h squared 10 alpha cot alpha. Kasongo mbona webo. Songaribara. Oh, yeah. Kasongo mbona webo. Songaribara. Hey. Now folks, what are we doing now? Okay, let's be systematic. We don't need to rush. We don't need to cry. So is there any like terms here? Yeah, man. Because this one, kodwa ingathi inkinga yethu izoba ningi ntswana yadi ntswana. You know, I am seeing something I don't like. Yo, this thing is busy now. Did we do all the right things, guys? Yes, looks like we did. But now we left something. Remember this 2, guys, is still here. It is not gone. We see. We believe. Now, what are we going to do, guys? Hey. Yeah, me. This thing is doing things now. I see 10 everywhere. Okay, so guys, this is easy. It means what we have here, we've got 4h into, we change this as 1 over 10 squared alpha. This is what this is. This is h squared 10 squared alpha. So this is going to be plus 2h squared into, we have 10 alpha into cot is 1 over 10 alpha. All right. So guys, unfortunately, certain expressions can be a horrible experience, as you can see. But hey, let the magic do its own thing. Do not be in a hurry. So these kinds of problems, guys, are not problems you're going to solve with impulsiveness or impulsivity. These are problems you solve with, a sweet approach. So here we have 4h squared divided by 10 squared alpha. That's what that bracket simplifies to. Plus, now this one, what is the stories here? Yeah, man, the stories are like this. Now this is h squared 10 squared alpha over 1, and then we have plus 2h squared over 1. Sometimes when I get to this and I'm thinking, yay. It is on Kalela. So we divide nicely by this one. That is the one. And we can already see that something is cooking here. I don't know why I delayed this thing. Goodness. Yeah, doch. Why did I? Cot we can change, guys. Let's let the magic keep happening so that we don't suffer. So this is 1 over 10 squared alpha. Let the magic happen. Ne? Yeah, man. We continue here, guys. So BD squared is equal to, now what do we have over there? Everything seems to be doing all the things. So guys, what we have now left, because this is just 1 on the denominator, so we just simply want the common denominator of those situations right there. Now this is nothing but 10 squared alpha. Now when we divide by that, it's 1. We get 4h squared. Plus, we then divide by 1, we get itself, we multiply there, we get h squared 10. Now 10 squared alpha times 10 squared alpha is 10 to the 4 alpha, and then we divide this by 1 over there, then we get essentially plus 2h squared 10 squared alpha. This is what we have. Can you see it's taking shape? We're starting to see what we want to see. We continue, guys, and say, all right, BD. Now remember, these crazy questions, guys, they take a toll on you if you're not careful. So we can see we've got the highest common factor here, which is h squared. So we have h squared into what remains. Now we can rearrange this so that it looks nice. We take the highest exponent to lead the way. So it's going to be 10 to the exponent 4 over, not over, 10 to the 4 alpha, right? This is the greatest or the biggest power. Power meaning the whole expression, please. And we know the order by its exponential value. Fundisa imaths ke ngokuhayi le nyaka manifunda lana phayana. Nofunda into eze-right man. Noba ngathi ndiyahlanya, anginandaba. Ngihlanya in the right way. Ndilihlanya le-right. Finish and clear. Now, what is the stories now? What is left here? 2. This is nothing but this one is going to be 2 10 squared alpha. Is it alpha or alpha? Is alpha. Don't talk nonsense, Mr. Sir. So siqhela kakubi kwedeni. Kodwa ninganibizi ngokwedini, ndikutateni abanye benu. Uyafumana. Hey, ingathi seyihlangene ndibona senivuyile nje senithetha into engapheli. It's because I can see where I'm going now. Now I can take the square root. What we do, ordinals, BODMAS, boys and girls, ladies and gentlemen, mummies and daddies, uncles and worms. Is it worms and dummies? Hey, and grannies, man, and grannies and madalas there. Yeah, this one is the one. So this is going to take us to BD, exactly what we want, equal to. Now, when we take the square root, this is a product, h out. Thank you, guys. You are such a nice bunch of people. You technically listen, but now this one, we can't do much about it. We just leave it as such. So this is going to be 10 to the exponent 4 alpha plus 2 10 squared alpha plus 4 divided by, now the square root of 10 squared is just 10 alpha. Iyo kanye iphume inje ngoba injalo. Besiyibona ke kodwa ba into efuneka siyenze nje funeka siqaphele nje esikwenzayo nje kuphela nje. Fanele nje siqaphele nje ngaphandle kwalokho konke sekuhlangene nje sekuvuthiwe sesiyakuphaka. Okay guys, you can see here you need to understand and master your algebraic gymnastics or mathematical gymnastics. And all of these are summarized in the 3-step approach. So if you want to fool around, of course, do it. But if you use the 3-step approach systematically, you will never get lost. All you need to do is to just concentrate, pay attention and be meticulous, be exact, be watchful. Reason through the problem so that when you see something strange or you feel like you're getting stuck, you double check if you're not making a mistake elsewhere. So guys, this is too heavy. I don't have the time to say where the marks are. Please leave me alone. All right. So we're going to do 6.3.3. Hence determine the height of the tower CD rounded off to the nearest meter. If alpha is that, BD is this. So what is the height of the tower, guys? CD is actually h, and we have h in our expression, so we just isolate that. So what do we know? We know that when we cross multiply, okay, maybe let's write it. BD has been found to be h into the square root of 10 to the exponent 4 alpha plus 2 10 squared alpha plus 4 divided by 10 alpha. And of course, siphungule nje. Re fokola nyana wabona, ekare ke e ngata jwale. Re tlo e fokola hanyane fela. That one, BD is this 509 equals H multiplied by. But guys, you know what? Yeah, doch. This is the one. Anyway, this is going to be 10 to the exponent 4 of alpha. What is alpha? 48 degrees. Plus 2 10 squared. 48 degrees plus 4 divided by 10. 48 degrees. Then we take it down a bit. Now we can fix it. Say this implies, when we isolate h, I mean this is over 1, right? Then we cross multiply this thing. And then we isolate h. We know that h is going to be equal to 509 times 1048 degrees divided by that square root. So this is 10 to the 4 of 48 degrees. In fact, the best way to write it so that we can sort the problem is this way, is to write 10 48 degrees all to the exponent 4 plus 2 into 10 48 degrees squared plus 4. That is the best way to sort this thing out. Let's see, therefore. Now this is all calculator work, folks. Fraction button, we've got 509 into 10. Now be very careful with these calculators. Make sure the brackets are enough to not mess up the expression. So we've got 10 48 all to the exponent 4 plus 2 into 10 48. Make sure the brackets are good. That is squared, and then we add 4 to that. And then let's get our answer. Whether it's wrong or right, I am not interested, if not interested. We're told to round off to the nearest meter. I'm getting 200 meters. Beautiful. This is convincing. But of course, with these kinds of calculations, you want to double, triple, and quadruple check that everything you have done is good, because these are marks on offer in the exam. All right. Okay. All right. So guys, this is also good, and I will not waste time with the marks at the moment. I'm just interested in saying if this is right, that's what we got, for a total of 22 marks. Okay, that ends our trigonometry revision session for today. I do hope you will learn these, practice this. Again, guys, in the description of this video, I am going to attach this question paper nicely cleaned so that you can actually try it out. Believe me, you may have seen what I did. You will get stuck. Believe me, you will get stuck in some of the questions. And when you get stuck, don't go and look at the memo. Try it out until you figure it out, until you remember some of the things you've seen. I mean, the best way to study, guys, there's multiple ways of studying. Some people choose to strain themselves, then relieve themselves later. If it works, it's good. Some people believe in watching first, seeing what's cooking, what's the logic, so that they can emulate the idea. And I think that's the best way. When you don't know anything, of course, but if you know something, try it first, then check later, and then try it again. Once you feel you've mastered it, then move on. But if you don't know anything at all, watch what you have seen, then try to replicate it without looking at it, but trying to reason through yourself, trying to remember as much as you can. Get stuck. Don't look at the answers. Don't look at the memo. Forget about it. Go drink water, go walk, talk to friends, think about something else. But remember, the question will remain in your brain. It will be intrigued enough to work it out until you remember something you were missing. Then you do it until you get it right. Then you can look at the video again. Oh, this is where I got it wrong. This is where my thinking was broken. Then you try it again. Once you feel confident, now you've got it, you can try any other question. Of course, they will be slightly different, needing slightly different techniques. I mean, there's plenty of videos in the channel to try and supplement that if you need more supplementation or complementation or whatever you call it. Then if you practice each one of those things as I am showing you guys, I promise you, if you can work through the videos in this channel, from the very first video to the last in maths and physical science, I can promise you guys, you may not even need a lot for your exams. But remember, you're not just purely going there to pass. You must learn to understand, so that as you progress further, you're going taking higher learning, courses on these subjects, be it maths, be it applied maths, physics, or applied physics. You will essentially thrive on your own, because there you will be on your own, guys. There will be no one looking after you. There will be no one teaching you everything. And in fact, if you start doing this nonsense of getting past exam question papers at university as well, ooh, yana, you're going to make a very crappy professional. One that can lose a job easily if you are hired by somebody who can fire you, or you come and become a weight that is so heavy on the government, because we've got lots of those people in the government. Because the government doesn't want to fire people. They don't even care to look at audits and see if people are meeting the standards that are set. They don't even set standards. They're just written on paper. Nobody makes sure those are implemented and there's results. There's accountability where there's gaps. No, they don't care. This is why the government sector is failing. There's a whole lot of people who don't belong in certain jobs. It's even worse now. You find that if an uncle works here, then the niece, even if they're not qualified, they cook the qualifications, they put them in. And you will see that those departments start failing heavily, because those people need to strictly focus on protocols that are put in place for them to function. Outside those protocols, they don't know anything. Because you'll find that when you want something, they'll tell you, no, but you need this first. And then you're like, come on, man. There is evidence that this has been done elsewhere. You can't have it now the way you want it. But work it out. They don't understand that they can do it because they are not qualified for those jobs. They're just sitting there. One big problem is our HR in our hospital. The HR is horrible. You can tell those people have been put there by those who love them, but those people did not qualify to be in those jobs. And this is because even if they did pass at varsity, when they did, or at college, or wherever they went, it means they used past exam question papers, and therefore they passed, because the exams are standardized, guys. But life problems and real life issues are not standard issues. These are higher grade issues. You need to use your brain, your knowledge, your skills, your ability to sift through the nonsense and take what is golden and run away with it as far as you can until you die. Anyhow, I leave you here, guys. Please don't cheat yourselves. These are not meant to replace your textbooks. These are not meant to replace your study guides. These videos are not meant to replace your teachers. They are meant to add to what they have done. So please use them as sort of like, preview if you haven't started lessons as yet. But if you have started lessons, you've started working through your textbooks, which is a good thing, then use these videos to summarize, now to put into perspective, to see how to use things in unison, in combination, in separation, in many other combinations you can think of. And at the end of the day, guys, you will see Term 1 exams are going to be a breeze. Term 2 exams are going to be a breeze. Trial exams may challenge you a bit, but you will still maintain a very high mark for a distinction. You won't just make it to the distinction. You will even try to leave it behind towards the hundreds. Then the final is going to be a walk in a park. But remember, whenever the exam looks too easy on face value, there's a whole lot of traps in there for you. So be very watchful, be meticulous, be diligent, be observant, stay awake, concentrate. That's the reason why I'm making these long videos, for you guys to learn to endure, paying attention and, concentrating for long hours, because you'll be writing for 3 hours in the longer exams and you will feel like you are burning out because you're not used to. So don't get used to eating smaller chunks. Use smaller chunks to build, foundations. Then take the bigger chunks to build endurance. Then you are going to be good to go. Time is not going to be even an issue for you to worry about. It's just going to fall into place. Trust me when I tell you this. I have always had more than enough time to review questions from the beginning to the end. I've always had time to go and do questions that probably gave me an issue, and sometimes enough to even crack it, because you will have banked a lot of time if you strategize in how you do your papers, provided you have the right knowledge, correctly applied, and well executed. All right, guys, I'll talk and talk and talk, but it never ends. At the end of the day, it is upon you to use these for your own good rather than for your own peril. I'll see you next time. Goodbye.